Today we are going to deal with the Gaussian integral. This Gaussian integral we are going to use frequently to solve the quantum mechanical problem. So it is a very important integral. Let us say I is equal to the Gaussian integral, which is equal to integral between minus infinite to plus infinite e power minus x squared dx. So this e power minus x squared is a Gaussian in nature. So now what we are going to do is just to square this. If you square that integral I square, then this will become integral between minus infinite to plus infinite e power minus x squared dx whole square. Now I am going to expand this. That is integral between minus infinite to plus infinite e power minus x squared dx multiplied by integral between minus infinite to plus infinite e power minus x squared dx. Here x is a running index. We can change this into y. Second one into y. Just because changing the label, your result will not change. So I am rewriting this I squared as integral between minus infinite to plus infinite e power minus x squared dx, then multiplied by integral between minus infinite to plus infinite, then e power minus y squared dy. So we can combine this and we can get double integral e power minus x squared plus y squared dx dy. Now we can write this x squared plus y squared as r squared. So this also we can write in the r theta coordinate system. This will be equal to r dr d theta. So I have replaced x squared plus y squared as r squared. That is integral between 0 to infinite e power minus r squared r dr, this one r dr, and d theta. D theta is integral between 0 to 2 pi. This r varies from 0 to infinite and theta varies from 0 to 2 pi. So the value of the first integral is 2 pi. Then you can keep second integral as it is. I squared is equal to 2 pi times integral between 0 to infinite e power minus r squared multiplied by r dr. Now we will simplify it further. We have started with the integral I is equal to integral minus infinite to plus infinite e power minus x squared dx. From this we got I squared is equal to 2 pi integral between 0 to infinite e power minus r squared r dr. Remember that here it is minus infinity. Here it becomes 0. Here the limit is 0 to infinite. Here minus infinite to plus infinite. You can see this is the add integrand. If it is symmetrical limit, this will be 0. Or naturally, without doing any assumption, we got the integral. That is change in limit of integral from 0 to infinite instead of minus infinite to plus infinite. That is a very important point. Now you take r squared as u. This r squared as u. This r squared as u. Then what is tu? Tu is equal to 2rtr. RTR. What is this RTR? We like to change this RTR. You bring this 2 to the other side. This will become 1 over 2 TU. This will become 1 over 2 TU. Now you replace all this thing here. That is you have 2 pi and this integral 0 to infinite, and this is half du. r will become half du. Then e power minus r squared become e power minus u. So now you can see this 2 and this 2 will get cancelled. So you will get pi, and if you integrate e power minus u with respect to u, you will get e power minus u over minus 1, because if you integrate minus u, you will get 1 over minus 1. So now you apply the limit infinite to 0. If you apply the upper limit, e power minus infinite is equal to 0, and e power 0, what is e power 0 is 1. So 0 minus 1, then minus 1. So the terms inside the bracket is minus 1 divided by minus 1, which is plus 1. So this I squared will become pi. That means I is equal to square root of pi. So that is integral. This actual integral is I is equal to square root of pi. Actual integral is integral between minus infinite to plus infinite e power minus x squared dx is equal to square root of pi. This is the Gaussian integral. Now we will see what will happen if there is a coefficient, that is e power minus alpha x. That we are going to see now. And now take the integral of the form integral minus infinite to plus infinite e power minus alpha x squared dx. Earlier case, this alpha is 1, that is just e power minus x squared. Now you have one alpha. You do the adopt a same procedure which you have carried out in the case of e power minus x squared dx. So we are going to square it, and we are changing the label x squared as x squared plus y squared, as we have done previously. So this double integral e power minus alpha multiplied by x squared plus y squared dx dy. This dx dy can be written as in r theta form, r dr theta, as done earlier, and this is r squared. So this integral can be written as, with respect to theta, 0 to 2 pi theta, and 0 to infinite, because r varies from 0 to infinite, e power minus alpha r squared r dr. Then you keep this as u. So u is equal to alpha r squared, and tu, what is tu? If you differentiate r squared, you will get 2r. Already there is alpha. This will become 2 alpha r dr. So now what we want is this r dr. So RTR is, if you bring this 2 alpha to the other side, that is this 2 alpha to other side, this will become 2 alpha, sorry, tu by 2 alpha. So this is 2 pi. So I am replacing this by 2 pi, and here tu 1 over 2 alpha. 1 over 2 alpha I am bringing outside, as alpha is a constant. So this will become e power minus u du. Here 2 will get cancelled. So you will get pi alpha, and integral of this. The integral of this is equal to e power minus u over minus 1. That is, you have to apply the upper limit and lower limit. So for upper limit, this is 0, and lower limit, this is minus 1 divided by minus 1. As done earlier, this will be equal to 1. So this integral I squared is equal to pi over alpha. That means what is I? I is you have to take square root of this. So I, that is integral between minus infinite to plus infinite e power minus alpha x squared dx is equal to square root of pi over alpha. This is the Gaussian integral when there is a coefficient for x. So this is the Gaussian functions. Thank you very much for watching my video and supporting me continuously. Thank you very much.